everyone, welcome back to our state space analysis lecture series. This video is a part of our lecture series focusing on helping us to understand the core concept of modern control systems. So in this session, we are going to explore the controllability and observability, which is the two basic properties that determines whether the system can be fully controlled, fully controlled as well as monitored. Let's start with these sessions. Let me explain what is the controllability first. So, a system is said to be controllable when we can move it from the initial states to the desired final state with the finite time using appropriate control inputs. This means we have a complete authority over the system behaviors via the input signals. So mathematically, we can use the Kalman's test for analyzing this controllability. So this Kalman's test, which has the controllability matrix of Q of Q naught, which is equal to B A B A square B up to A power n minus 1 into B, where n is the rank of the matrix. If the rank of this matrix equals the number of state variables, then the system is controllable. And this is the conditions for your controllability. So if you are finding the determinant of Q naught, that is the controllable matrix. So if the determinant is not equal to 0, we can say that the system is controllable. If we are finding the determinant which is equal to 0, and we can conclude that the given system is uncontrollable. So this is about the controllability, and next we are entering into the observability. A system is said to be observable if we can determine all its internal states by examining the outputs over the time. This is critical when direct measurements of every state is not possible. We can use the output data to reconstruct the full system behaviors. So again, here also the Kalman's test is used to find the observability matrix, which we are naming it as Q naught, which is equal to C transpose A transpose C transpose, and it will extend up to A transpose power n minus 1 into C transpose. Again, n is the rank of the matrix, and here also the n matters for the observable. If we are going to find the determinant, if the determinant of the matrix Q naught is not equal to 0, then the system is completely observable. So these are the conditions for the observability. As I said earlier, the determinant is equal to 0, then the system is not observable. If it is not equal to 0, we can conclude that the given system is observable. Next, we can explain this controllability and observability in terms of engineering applications. First, we are going to see how it will be works in the aerospace, then robotics, chemical process, as well as biomedical. So, in the aerospace, in flight control and satellite navigations, we are using the controllability to ensure the path corrections as well as the observability helps in the state of tracking the sensors. Whereas in the robotics, which enables the precise control of robotic arms and autonomous decisions based on the observed data. Next, in the chemical process, we have the monitoring and controlling variables like temperature, pressures in the reactors for optimal outputs. Finally, in the biomedical field, we are ensuring the accurate delivery in the drug infusion system or relating anesthesia in the real-time worlds. Next, we are going to discuss the same concept, controllability and observability, with some case studies and also examples. So, let's look at the real-time scenarios. We are going to see about quadcopter stabilizations. So here, the controllability manages the motor inputs to stabilize the flight, and observability uses the data from the sensors to estimate the positions and velocity. Whereas in the chemical plant control, with the temperature and the pressure sensors, which ensures the key variables becomes observable and enabling the precise control decisions. And in the flow rate controls, the pumps and the valves adjust based on the flow feedback, and we can say it as another live examples of concepts in the actions. So before concluding these sessions, the controllability ensures we can drive the systems where we want it to go, while the observability allow us to track and understand how the system behaves. Both the controllability as well as observability are vital for designing the reliable and effective control systems. So I hope you have understood some of the concepts of controllability and observability. Some other interesting topic we will meet in the next video. Thank you.